Statistics can seem absolutely bizarre, and often they can seem completely strange and often unbelievable. And there's no better example of this than the statistics problem, the Monty Hall problem, which is based off a TV show from the 1960s and 1970s. But what is the Monty Hall problem and what makes it so unbelievable? So back in the 1970s there was a TV show called Let's Make a Deal, hosted by the very charismatic Monty Hall. And one of the rounds of the TV show, the contestant was shown 3 doors, and behind one of the doors was a really special prize, behind 2 of the other doors were not so great prizes. So for our example, let's say the prize we really want, the good prize, is a brand new sports car, and the 2 prizes we don't want are just boring old goats. So first Monty asks you to pick which door you think the car is behind. At this stage there's a 1 in 3 chance you correctly find the car, but next comes the really interesting part of the game. At this point, Monty opens one of the closed doors that has a goat behind it. Now because there are 3 doors and 2 goats, it means whichever door we picked first, one of the closed doors always has a goat behind it. This means the 2 closed doors we have now are 1 car and 1 goat. Now next comes the really important point within the game show and within the Monty Hall problem itself. And Monty asks you one vital question. Would you like to stick with the door you originally chose, or would you like to switch? So what should you do? Should you switch doors, or should you stick to the one that you originally chose? It's a simple problem, right? There are 2 closed doors, one has a car behind it, one has a goat. It's a 50-50 shot. Half the time you pick the car correctly, half the time you pick the goat. Well actually it's not quite this simple, and a lot of people thought it was until 1975 when the statistician Steve Selvin proved otherwise, and actually came up with this incredible fact: you should always swap. So why did he say you should swap? Well, let's take a really simple look at the problem. There are 3 doors in front of you, let's call them door 1, door 2 and door 3. And let's say at the beginning you choose door number 1. Now there is a 1 in 3 chance that the car is behind door number 1, the one you picked. And this means that there's a 2 in 3 chance that the car is behind the other 2 doors. Next, Monty reveals one of the goats behind the other closed doors, let's say door number 2. And the integral part of this problem is that Monty always knows where the car is, so he can always correctly show you where the goat is. Now there's still technically a 2/3 chance that the car is behind doors number 2 or 3. But we can see that the car definitely isn't behind door number 2. And this is because it's open and we can see the goat there. So what this means is that all this odds, this 2/3 chance, is now all focused on door number 3. i.e. there's a 1/3 chance that the car is behind door number 1, the door you first picked, and a 2/3 chance that it's behind door number 3. This is completely crazy, but what it means, as you can see, is that in this circumstance you should always swap to the door you didn't first pick. Another way of saying this is that there are 3 possibilities. If you first chose the car, then swapping will mean you definitely pick a goat, either goat number 1 or goat number 2. The second option is that you chose goat number 1. In this case, if you swap, you will always pick the car, as goat number 2 has already been revealed, so you win. Finally, the third option is that you pick goat number 2. Again, if you swap, you'll swap to the car, as goat number 1 will have been revealed by Monty Hall. So there are 3 possible starting options, and one of them leads to you going home with a goat, but 2 of them see you driving home your brand new car. But of course, it doesn't mean you'll win all the time if you swap. You're just twice as likely to win if you do change your mind. So let's do a real life demonstration of this. Now here I have 3 cups. Cup number 1, cup number 2 and cup number 3. Underneath one of these is the ultimate prize that we want to win, which is just a ball of string, which isn't that good, but you just have to bear with me. So first things first, we need to pick one of these mugs. So let's say we pick mug number 1, okay? So Monty Hall, the host of the game show, is now going to reveal one of the other mugs. One of the mugs that has nothing underneath it, it doesn't have the ball of string. So let's say he reveals mug number 3. There's nothing underneath mug number 3. He knew that because he knows where the ball of string is. Now I have an option now. Do I stick with the mug I originally had, or do I switch to the other mug? Well, logic says that I should switch to the other mug, because when there was a 1/3 chance underneath this one, there was a 2/3 chance of it being underneath one of these 2. But with this one being shown there being nothing underneath, there's now a 2/3 chance that the ball of string is underneath this cup. So what should I do? Well, if there's 2/3 chance, I should obviously switch to this one, which in this case would have definitely been the correct decision. But 1/3 of the time, it would still been underneath this mug. So 1/3 of the time, I would have lost. It's just that the odds are better if I switch to this mug. But this might be hard to think about, because 1/3 and 2/3 aren't that much different from each other. So let's exaggerate the problem. Let's say there are 100 doors. One of the doors has a car behind it, and the other 99 all have ghosts. Now you pick one door at the beginning. You pick, say, door number 1. And then Monty will reveal all the other doors apart from door number 1 and one of the other doors, let's say door number 40. Now we know from when we looked at the problem earlier that all the probability of it being behind the doors that were revealed all get pushed onto the other door that's closed, i.e. all the 98 out of 100 chance that the ghost is behind the door from all the doors that Monty opened earlier all go onto the closed door that you didn't pick originally, door number 40. So what this means now is that there's a 1 in 100 chance or a 1% chance that the car is behind door number 1, the door you first picked. But there is a 99 in 100 or 99% chance that the car is behind door number 40. If you play the game 100 times, on average 99 times out of that 100, the car would all be behind door number 40. Incredible and hardly believable. And I know this seems completely strange, and you may still not believe me, and you wouldn't be the only one. When it was first published in a magazine in 1975, many mathematicians wrote into the magazine complaining that the magazine would publish such terrible mathematics. And it was only with computer simulations, when computers could redo this millions and millions of times, and it was shown that this was completely correct, that many people came around to accepting that this is a reality, however strange it seems. So there you have it. Statistics are said to often lie, but however strange it is, the Monty Hall problem is completely true. And if you're ever faced with such a problem, just remember you should always switch. Thank you very much for watching my video. Don't forget to check out the rest of my channel. Don't forget to like, subscribe, and leave any comments or questions you have, and I'll always try and get back to you. Otherwise, thanks for watching, and I'll see you all soon. Most of us learn to use the toilet by the time we're 3, and we've mastered it by 5. But we have it really easy down here on Earth. Gravity helps move things along, we have water to flush everything away, we have massive sites to get rid of all the waste and clean the water before sending it all back out.